In this video, I will explain the comparison of the two equations I chose, being hydrogen gas, nitrogen gas, to make ammonia, and zinc nitrate and potassium to make potassium nitrate and zinc. Now I'll write the skeleton chemical equation. For hydrogen gas, it would be H2 plus nitrogen gas, N2, and ammonia is NH3. A compound's elements needs to gain or lose electrons to create a full valence shell. So, since zinc is a transition metal, we refer to its oxidation state, which is 2. So, we put its superscript as 2. Now, referring to camel, we know nitrate is NO3 with a superscript of 1. Remember, superscripts are valences. Using the crisscross method, we will take the superscript of 2 and bring it over here, and the superscript of 1 and bring it over here. Now, we're going to have to put brackets around nitrate because it is treated as a single element because there's a polyatomic ion. Since zinc wants to gain 2 electrons and nitrate wants to lose 1 electron, we give zinc an electron from nitrate. Now, that first nitrate is a full shell. However, zinc still has 1 left. So, we need to add a second nitrate. Now, zinc is a full shell, and both nitrates are a full shell. When balancing a chemical equation, the products and reactants must have the same mass and contain the same elements. For this to happen, we need to take the skeleton chemical equation and make sure we have the same amount of elements on each side of the equation. You can't simply change this number. You add a coefficient in front of the element or compound to balance the equation. Adding any number of coefficient will multiply the number of the element by the coefficient. So, for hydrogen and nitrogen, I have 1 nitrogen on this side and 2 over here. So, I must give 2 nitrogens there. So we're going to put a coefficient of 2. But now, since we times the coefficient by the subscript, I now have 6 hydrogens and 2 over here. So, 2 times 3 would be 6. So I add a 3 coefficient in front of hydrogen. Now, I have 6 hydrogens here, 6 hydrogens here, 2 nitrogens here, and 2 nitrogens here. That equation is balanced. Let's balance this equation. In this equation, we have 1 zinc here and 1 zinc here. We have 1 potassium and 1 potassium. So we don't need to change those. We also have 2 nitrogens and 6 oxygens. 1 nitrogen here and 3 oxygens there. So this part is not balanced. What we're going to do is we're going to put a 2 in front of the K and O, 3. So we'll have 6 oxygens, 2 nitrogens, 2 nitrogens. Let's go ahead and do that. Since we added that 2, we now have 2 potassiums. So we're going to put a 2 in front of the potassium. This equation is now balanced. Let's talk about some safety concerns and uses. Some uses for zinc, for example, would be sunscreen, due to its nutritional benefits. A safety concern for ammonia would be that it is corrosive to the skin and eyes. Reaction types are determined by the differences of reactants in the product. Synthesis, which is this equation, is two or more reactants combine to make a product. Decomposition is the opposite of this. It would be when one product breaks down to two different elements. Double displacement is when two parts of two compounds switch places. Single displacement, shown here, is a single element replaces another in a compound. Zinc gets replaced with potassium, and potassium is replaced with zinc. So, you get potassium nitrate and zinc. A comparison is that each equation has at least one nitrogen. Let's compare and contrast these two equations. In this equation, it is synthesis, which is different than this equation, which is a single displacement. That is just one of the many contrasts it has. Another contrast is that this equation has more elements than this one. So how do you know that a chemical reaction has taken place? Well, we can tell by Chagall. In this equation, a gas is produced. Hydrogen gas plus nitrogen gas equals ammonia gas.